Hello everyone. So I am Dr. Y. Padma Sai, Professor ECE, VNR VIGNANA JYOTHI Institute of Engineering and Technology, and I am also serving as the Chair, Student Activity Committee, IEEE Hyderabad section. Today we are going to discuss about operations on signals. Last two classes we have discussed about basic signals or elementary signals, and next class classification of signals. Now we have to see some of the very important fundamentals on operations of signals, that is time shifting, time scaling, amplitude scaling, time reversal. So coming to time shifting. Okay, I have used example while explaining causality, but I didn't tell what is time shifting, all those things. But now if you consider time shifting moves a signal left or right along time axis, that one we are calling as time shifting. Suppose if you take positive time shift, for example, I want to shift my x of t towards x of t minus t. For example, I have one signal. Okay, so I am having one signal. For example, I am having one pulse. So this I am calling as x of t. So if I want to calculate or shift, always positive time shift. Positive time shift we are calling as time shifting. That is, here I am shifting my signal by t naught duration. So that is, this is t, this is x of t minus t naught. This one we are calling as delay. Suppose instead of shifting towards right, actually always if it is delay, we are shifting towards right. That one we are calling as delay. So entire signal is shifted by t naught units. Okay, for example, you are having x of t. Suppose if you want to shift x of t minus 2, the entire signal instead of starting at 0, it starts from 2. That one we are calling as delay. Always delay is shifting towards right. Next one is advance. Advance is negative time shift. So for example, previously I am having x of t. Now I want to shift x of t by, for example, x of t plus t naught. T naught. So now in this case, your entire signal is shifted towards, I am not mentioning what is the t, by minus t naught. The signal now, instead of starting at 0, entire signal shifting towards left by minus t naught units. Okay, that one we are calling as advance. Advance is always shifting towards left. Okay, so for example, here given example, so you take x of t is given, it is having a triangular pulse, assume it is having minus 1 and plus 1. Okay, in this case we are shifting, here it is not mentioned whether it is t naught is 1 or 2 or not. So entire signal is shifted towards right. Okay, so that is delay. We are calling that as delay. Always delay is shifting towards right by that many number of units. So x of t plus t naught. So you may get doubt, even though you are shifting left. For example, in this case, for example, you consider one signal. In one shifting, for example, I got my signal from 1 to 2. Okay, so this one I am calling as, so some signal, whatever it may be, x of t. Okay, so next case what I want to do is, I want to shift this signal, this is called t. So for example, I want to shift this signal by x of t plus 0.5. So during that case, what happened? The same signal you will get, but here your axis only it is moved to 0.5 to 1.5. This is only 1, so this is only 1.5. So even though it is positive pulse only, so all the time your signal may be positive or may be negative. You should not say by seeing that signal. By seeing the duration, you should be able to clearly tell how your signal is moving, whether it is moving left or not. So whenever it is positive shift, x of t minus t naught, positive shift, that one we are calling positive shift, the entire signal is moving towards right by that many number of units. That one we are calling as delay. In the case of advance, the signal is shifting towards left by that many number of units. I will explain for mirror image after next slide. Coming to the same concept for discrete time signal. Okay, so for example, I am having my signal x of n equal to 1, 2, 3, 4. Now here I am having my signal. So I didn't mention that point. Whenever it is not mentioned here in this case, you take, this is one of the representation type. Okay, here it is not mentioned what is your 0 axis. If it is not mentioned, your signal is starting from 0 only. This is 1, this is 2, this is 3, this is 4. This 0, 1, 2, 3. It is having 4 samples in my signal, having 1, 2, 3, 4 as amplitude. Okay, now what I am doing? I am doing delaying of my signal by 1 unit. So when I am doing delaying by 1 unit, what happens? Entire signal is shifting towards right by 1 unit. So previously you are having signal from 0. Now your signal is shifting towards right by 1 unit. So because of that, all your 4 samples are shifting. This is 1, 2, 3, 4. Previously you are having 0, 1, 2, 3. Now at 0 you are having sample as 0. So because of that I mentioned here, you see clearly in the delayed signal you have sample 0, 1, 2, 3, 4. Okay, is it clear all of you? So now coming to advance. In the case of advance, for example, if you take x of n, if you want to write x of, this one is x of n minus 1. For example, always you have to consider original signal x of n plus 1. You should not take in between signal. Only you take x of n and that signal should be shifted towards left by 1 unit. So instead of starting your signal at 0, now in this case your signal starts from 1. Okay, that is minus 1, 0, 1, 2. So because of that, so I have clearly mentioned at 2, actually arrow is shifted. So here it is arrow. Arrow is the demarcation. Arrow indicates it is 0. All left side negative, minus 1, minus 2, etc. All right side positive, 1, 2, 3, etc. So because of that, you clearly see here. So when you are shifting n plus 1, entire signal is shifting towards left by that many number of units, that we are calling as x of n plus 1, that is advanced. For example, I am having mirror image of signal. So for example, you take, so x of n is equal to, so once again I will explain time shifting property. So just now we studied. So now here I am having signal at 0, it is having 1, 2, 3, 4, 0, 1, 2, 3. Okay. So now I want to calculate time reversal or mirror image of the given signal. That we are calling as x of minus n. X of minus n is, so okay, whatever sample I am having at 0, the same sample will retain. So whatever sample I have at 1, it will come to minus 1, and 2, it will come to minus 2, and 3, it will come to 3. The amplitude is same, 3, minus 2, minus 1. At 0, it is having value 1. Okay, this is 1, 2, 3, 4. In this case, it is 1, 2, 3, 4, amplitude of the signal. So now I have to compute x of minus n minus 1. Just now I mentioned in previous case, so I will once again rewrite that one. X of minus 1 means for positive signal, always it is delay. Delay means shifting towards right. If it is x of n plus 1, it is advance. Advance means shifting towards left by that many number of units. So, but when you are considering mirror image signal, okay, the concept is little bit reverse. X of minus n, n minus 1, minus 1. This is, in previous case it is delay, now it is advance. Whenever it is advance, always shifting towards left. So coming to x of minus n plus 1, this is delay. Delay means always shifting towards right. So, okay, now according to this concept, now we have to shift this signal, anti-signal towards left by 1 unit. So, because of that, instead of starting your signal at -3, your signal starts from 4. At -4, it is having value -3, -2, and -1. So, at 3, it is having, and 2, it is having. So, okay, so now, so shifting only x of -n, I am shifting towards left by 1 unit. So, because of that, previously your sequence is starting from -3. Now, in this case, your sequence starts from -4 and -3, -2, and -1. At 0, you don't have any sample. This 4, 3, 2, 1. Altogether, I have only 4 samples. This one I am calling as, for mirror image is the x of -n. For original, I am calling as x of n. If you take mirror image or time reversal, we are calling x of -n. So, for that, reverse of for positive sequence. This concept is very important when you are discussing about convolution. Next one is time scaling. So, this is also one of the very important concept, mostly used in communications and image processing. While transmitting the data, we are having restricted bandwidth. Because of that, generally we are compressing the signal at the transmitter side, and at the receiver side, once again, we are expanding. So, how will you do that? So, by using the concept of time scaling, whether you can do compression or expansion of the signal along time axis. So, now for example, if you see x of t equal to sin t. If you want to compress the signal, what we are doing is, we are multiplying t by 2t. So, during that time, x of sin 2t you will get. So, frequency increases, signal compresses. So, coming to expanded, x of t equal to t by 2, that is sin t by 2. Frequency decreases, signal expands. I will explain this concept in a discrete case. It is easy to understand when you are considering discrete. Now, for example, if you see the time scaling, for x of at is time scaled version of signal x of t, where a is always positive. So, now time compression, mod a greater than 1. During that case, the signal is compressed. So, here clearly mentioned, you see. So, initially x of t is given here. So, now after that, we are multiplying x of t by 2. A is greater than 2, greater than 1, that is equal to 2. During that time, previously your signal is occupying time scale from -2 to 2. In the compressed signal, that is x of 2t is having -1 to 1. Okay, that one we are calling as time compression. So, in the case of time compression, a value varies from 0 to 0 and less than 1. During that time, the signal expands. So, for example, x of t by 2. During this case, your signal is expanded to -4 to 4. That one we are calling as time expansion. For step signal, this property is not valid. Why? Because u of at is equal to u of t. Time scaling is not applicable for step signal. Next one is the same concept we are extending to discrete signals also. At a time, both we are studying continuous time signals as well as discrete time signal. Okay, for example, I am having my xn. Xn is 1, 2, 3, 4. If I want to calculate x of n by 2, see clearly here. So, now initially you have signal. For example, here in this case, all positive samples only. It starts from 0, 1, 2, 3, 4. Okay, 4 samples. Okay, this is n, this is x of n. Okay, so now I have to calculate my x of n by 2. For example, you assume, I want to explain this. This is equal to x of n by 2. How I am calculating? I am calculating my y dash of n from my original signal. For example, I want to calculate my y dash of 0. My y dash of 0 is x of 0. What is my x of 0? It is having value 1. So, similarly, my y dash of 1. When I am calculating y dash of 1, what happened? X of 1 by 2. So because of that, I am not calculating. Only I have to consider all divisible by 1. So y dash of 1 is 0. Y dash of 2 is equal to x of 2 by 2. This is equal to 1. Similarly, y dash of 3, it is not divisible by 3. So because of that, that sample you are filling with 0. So now y dash of 4 is equal to x of n by 4. N is 4 by 2, that is 2. Okay, that is x of 2. So like that, what happened? So each and every, in between each sample, you are increasing, adding 1 0. So 1, 2, 3. Previously, I am having my xn is 1, 2, 3, 4. Now, for the same duration, previously my signal is occupying from 0 to 3. Now, when I am doing time sampling, that is time scaling, during that case, it is x of n by 2 is equal to, it is coming from, you take, this is 1, 2, 3, 4, 5, 6, 7. So previously your signal is from 0 to 3. Now your signal is extending from 0 to 6. Actually I started from 1. If you start from 0, it is extending from 0 to 6. Okay, that one we are calling as expansion. So in the case of compression, expansion sometimes we are calling as upsampling. So that we'll study in multi-rate signal processing. So that process we are calling as upsampling is increasing sampling rate. Okay, so based on that factor, in this case we are considering n by 2. So because of 2, we are adding 2 minus 1 zeros, we have to add in between each sample. That process we are calling as upsampling. Coming to compression, here we are multiplying n by 2n. So okay, similar to previous case, it is we are compressing the signal. So what we are doing is we are starting from same one and discarding. Here I am considering that decimation factor or downsampling factor. In this case I am 2. So in downsampling what we are doing is we are taking only one sample. In between each one sample we are discarding one sample. So because of that I am having 1, discarding 2, next 3, next discarding 4. So because of that, what happened? Your signal is, previously it is coming 0 to 3, now it is coming only 1 and 0 and 1. That we are the process we are calling as compression. Mainly in all communications and image processing, upsampling and downsampling, during that case we are using time sampling concept. Next one is amplitude scaling. Changes the amplitude of the signal. So only simply wherever based on that signal, each and every instant we are multiplying by whatever amplitude it is mentioned, that is multiplied by that factor. Here in this case we are that multiplying factor as 2, so it is increased by 2. So the same concept is valid for discrete time signals also. For example, here it is easy to understand. So x of n equal to 1, 2, 3. In the amplitude scaling, I already mentioned each and every position. Here I am having my signal 0, 1, 2. So now 0 I am multiplying by 3. At 1 I am multiplying by 3. At 2 also I am multiplying by 3. So why? I want to scale my amplitude by factor 3. Because of that, each and every instant I am multiplying by 3. So this is the example of amplitude scaling. So simply if you multiply, so original signal you are having amplitude 2. If you multiply it by 2, so here the amplitude of the signal is clearly showing amplitude is increasing. In the case of 0.5, amplitude is decreasing. So based on our application, you can increase or decrease. So next one is, suppose in some cases you want to add 2 signals. You want to subtract 2 signals. Simply adding means, so if 2 signals are existing, we can add. Okay, if both signals, by adding that one, you will get such type of signals. Addition of 2 signals is nothing but addition of their corresponding amplitudes. So for example, x of n is having value 1. at one instant. Similar signal also having amplitude 2. So 1 plus 2, 3. Now resultant signal you will get amplitude as 3. Corresponding position value you have to add, and resultant signal will get the combination of both. And similarly subtraction also. Subtraction also the same concept. Corresponding position value, so you have to take and subtract. Similarly multiplication also, multiplying each corresponding signal. If two signals are existing, then only you will get result. Otherwise, even though one is existing and one not existing, you won't get any output. So in this case, you clearly see. So x1t is minus 3 to 3. Even though x2t is existing from minus 10 to t, when you are multiplying these two signals, the resultant signal is existing from only minus 3 to 3. So this concept also very important when you are performing convolution. Okay, next one is time reversal. Time reversal means I already explained this concept during how we are shifting time reversal signal. So time reversal is nothing but only replacing t by minus t. Such type of signals we are calling as time reversal. Time reversal flips a signal about the vertical axis, about y-axis. Vertical means y-axis. So whatever sample you are having at 0, the same sample will retain. Remaining all other samples will flip. So see here clearly. So x of n is having 1, 2, 3, 4. So now because of the flipping, okay. So here actually this is wrong. So you have to keep this as arrow. This is your flipped signal. So during this case, 1 is as it is because of flipping. In previous case, 2 is here at 1. So this is 0, 1, 2, 3. This is 0, minus 1, minus 2, minus 3. Whatever signal you are having, exactly it is flipping. Sequence, reverse order. But axis also here it is mistake, not mentioned clearly. We have to represent that by using arrow. Okay, already we have discussed all these things. Time shifting, time scaling, amplitude scaling, time reversal. All these concepts are very, very important, not only for this course, even in DSP and image processing also, we are going to use this concept. All of you try to concentrate and learn well. So time reversal, example for this. Okay, so exactly opposite, it will change. Previously it is up to 2. Now when you are flipping, so the signal comes to minus 2. So we have successfully completed basics of signals and signals. So once again, I thank all of you for attending, and I also thank all the authors of these books. Mostly I am following from these books. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.